All right, so I think it's time for us to get started in here. Okay. So good morning, everyone. This is our week 2 Tuesday. We will be looking at basically a introduction of how to get started with your program and also loops. Okay, so that's the plan. A couple of things, logistic wise. Number one, for this week, tomorrow we have the lab. So lab 2 will be tomorrow. And this Friday, we have quiz 2. Okay. And also we released PA2 yesterday. So you should be able to see it and do it. So those are the 3 things still this week. For quiz 1, you can see the answers on Gradescope. So go there, check it out. But other than that, those are the logistics stuff. Next week, we have a midterm. Okay, midterm will be on Wednesday next week. There is no lab next week. Any questions before we get started in here? All right. So the plan for today is we'll first talk about how to get started with a coding project and then loop. Okay. So part 1 is coding habit. Because as expected, every one of us who are taking 8A is expected to be beginners, right? You may not have taken any coding classes before. So it's important that you kind of know how to approach a problem. And that's what we'll focus on in the first maybe 15 minutes or so. Okay. So a good habit, in fact, would impact your learning outcome not only in this class, but if you have any future CSE classes, it may impact those classes too. So all kinds of students needs better habits. And believe it or not, some of the most intelligent students, in fact, they may have very bad habits. Like they think they got everything, and sometimes they would just fail miserably under certain situations. So it's important that you kind of focus on developing a good habit. In the long run, it will help you. Okay. So what is a good habit? The first thing you need to know is computer science is really not about computers. Computers are tools for us, right? We just use computers to solve problems. That's it. It's just a tool. It's just like mechanics. They use wrenches, right? It doesn't mean they study wrenches. They know a lot about wrenches, but it's just a tool for them, right? So it's the same thing here. So computer science is mostly about problem solving. So most of your time should be spending on designing your algorithms. In other words, designing your strategies. And then you spend a small amount of time to code and test. Right? So it's more like you have this idea first, right? If idea is wrong, no matter how well you implement that idea, it's doomed to fail. So it's important that you have the right idea. And you do not want to spend too much time debugging your code, because debugging is a very frustrating process. You say, my idea is good, I implement it, it just doesn't work. Okay. You may start to doubt your algorithm. You may start to doubt your coding skills. You may even start to doubt, am I supposed to be a CS major? Right. I've seen this before. And it's just debugging is a very frustrating process. You don't know why something doesn't work, and you need to figure out why. So we want to limit the amount of time you spend on debugging, and the best way to avoid spending too much time debugging is you have the right idea to start with. If you have the wrong idea, no matter how well you debug, your code will be wrong. Okay. So let's kind of look at a case study, okay, of how I should get started in here. So this function is called sum2, given the list, right? You're given the list of integers, return the sum of the two elements in the list. If the list length is less than 2, just sum up the elements in that list, returning none type if the list is length 0. So that's the task. Like in the PA, oh, this is what I'm supposed to do, right? Now, how do I get started? Some of you start to type in the code right away. That's a big no-no, especially for beginners. If you have a lot of experience, you have failed. In other words, if you have failed enough times, like me, then you have learned those lessons, and then you would have know better of like what I need to consider. But for beginners, it will be so hard for you to come up with a solution that is correct right away, right? So you want to avoid typing in the code first, which is counterintuitive, right? Because you're graded on the code you write. How come you don't want me to type in the code? It's just like, for example, if you say you are a race car driver and you say we're racing on the track, but if you say I want to become a good race car driver, you don't say let me get behind the wheels first, right? You want to learn how to drive, maybe at least on paper in the beginning, right? Where is the gas? Where is the brake, and etc. So you got to start somewhere. You don't want to kind of go directly to coding in here. Just be careful, okay? So the first thing you got to do is you understand the problem. That's step number one. You understand the problem. I read it, I understand it. Not necessarily. Okay. You must test if you understand something or not. Then how do I test myself about something that I may not even understand fully? So this is when you design your test cases. These test cases will be very useful. They will be used throughout your entire coding process. Okay, so it's not something that you just use it once and throw it away. No, you use it for the entire process. Okay, so how do I design my test cases? In general, we would have given you some examples, right? And then you kind of start to understand the problem and design your own examples. I would say you need at least 10 tests, around 10 tests. Okay. So for example, how do I do it? You say, okay, sum2. If I give myself a list of 1, 2, 3, I'm expecting a 3 being returned, which is the sum of the first two. Yeah. So if I say sum2, 2, 4, 6, 8, I'm expecting a 6. Right? Maybe I have sum2, 1, 3, 7. This one will return 4. Right? These are normal cases. And as you try to design these tests, you also are teaching yourself how to solve these ones. Okay. I'll give you some time. Can you come up with 7 other examples? 7 more. Okay. Give me a vote once you are done designing them. Like just grab a piece of paper and write them down. Okay. You want to say you want to test a wide range of potential scenarios. Right? It's like you are organizing an event. You say, what may happen? What if it rains? What if someone doesn't show up? What if too few people show up? You just have to think about those scenarios. Okay. Can you come up with 7 more? If you are done with those 7 more tests, vote in. Okay. 3 of us are done, right? So you may want to design some tricky tests. I just say nice ones, right? If everything works according to plan, that's in general not what happens in reality, right? The only thing that doesn't change is the change itself. Everything is changing. All right. So let's look at, right. Let's look at this one. So tests, right? So I would say sum to. I would say if you give me negative numbers, I'm expecting a -3. So what if it's negative, right? Should work on negative numbers. What if I have some repeats? 0, 0, 2. So this one would give me 0, right? And now I will try to design something tricky. What if I give you an empty string? Well, since there's nothing in there, I should return none. If I say sum 2 with just one thing, 7. This one would return 7, right? Is it? Let me see. Returning non-type if the length is 0. Okay, so that's right. So in here is 7. How about sum 2? Just 2 things, and then I'm expecting this thing to be a 3. Right, so that's 5 more. I say, well, how about a longer sum 2, a longer string? 1, 3, 7, 10, 20, -1. And this one should just return 4. Right? And I think that's probably enough. I only come up with 6. But you want to kind of design the test that would encounter all kinds of scenarios. And that's how we test your code. So we're gonna test your code and see, okay, what we got. And so we pass in this thing to your function and see, do I get to -3? If your code also gets to -3, you get awarded the points. Otherwise, you don't. So that's what we need to kind of design yourself so you can test your code thoroughly. Now, okay, I have my test. What's the next thing? The next thing is not coding. The next thing is design on paper. And this part is very freestyle. So you can do anything you want to design your strategy. You want to write down like the important steps with as many details as possible, right? So for example, how do I design this thing? As you try to come up with these tests, I'm pretty sure you already started to figure out, okay, how did I solve it as a human? You just need to teach it to the machine. That's all. Okay. So I'm given a list. It looks like I just need to add up the first 2 elements. Right? That's my idea. I just add up the first 2 elements. Am I missing anything? How do I know if this idea is going to work? You just apply it to these tests. Add the first 2 elements. Oh, looks good. Add the first 2. Add the first 2. Add the first 2. Add the first 2. Add for. Okay, there's no first 2 in here. Now this one, basically you say if it's empty, I need to return none. Now you have to think about, well, how do I determine if something is empty, if a list is empty, right? Now how do I return none? These are the details that you should have learned from lecture. Sometimes students say, oh, the PAs are not related to the lecture at all. That's one of the common feedbacks that we hear from our students. And I can understand why, right? Because in the lectures we talk about the general strategies, and in the PA you have to apply them. It's just like when you take a English class, in the beginning, you learn how to spell words, but English is not about spelling words. So what we're teaching you all is how to spell the words, and it's up to you to use what you're learning here to make an article out of it. So there is a gap. There is a gap. So it's CS is slightly different from some of the math classes, for example, that you may have taken, where you're given similar examples. In here is slightly different. Okay. So you got to come up with creative strategies to solving different kinds of problems, but the cores are the same. Okay, you have these core tools, and you just have to apply it to different scenarios. Excuse me. So if the list is empty, I'll return none. All right. So looks like I've covered this case. How about this one? Oh, this one is not empty. The first one, the second one. I don't have a second one. The other thing is I have to say, okay, if only has one thing, then just return the one thing. And that's it. So I just you can scratch on paper, right? And you must apply this algorithm that you have on all the tests that you have in here. Make sure you pass every one of them. If you say, I missed this thing, now I refined my algorithm. I try to test again, it will pass this one. You need to test again on all these cases because it's possible that you design an algorithm, now it solved one of the tests, but it will fail the previously successful test. Okay, just like if someone unfortunately has cancer, they do chemotherapy, it will kill the cancer cells, but that person would also lose their hair, right? So it's just a side effect, and that's the same thing. You modified your algorithm, used to be a good thing, now it's possible that it may fail now. So you want to test again. So I think let's test them again. Oh, is this empty? No. Does this only have one thing? No. Then I just return the sum of the first two. So this one is good. Similarly for this one, not empty, not only one thing, had the first two. Similarly, as before, not empty, not one thing. In here, not empty, not one thing. So 1 plus 3 is 4. Not empty, not one thing, -3, 0. Oh, this is empty. Empty, what should I do? Return none. That's good. This thing, not empty, as one thing. What should I do? Just return that only one thing in here is 7. Return 7. Not empty, not one thing. Add the first two things, and that's it. So it looks like this idea would work. This idea would work. And now you're pretty confident that the idea is there. The next thing you need to do is you need to convert this idea into a piece of code, Okay. So how should I do this? You basically, I think we tested on paper, we add the test cases. Now you're writing code and start to debug. Be careful with syntax, right? Because for humans, oh, this makes sense. But for machines, it's just, remember, it's just a piece of silicon. It can't think, right? Well, now AI has developed a lot, but it's not thinking. It's still doing a lot of the very intricate designs, like using math. So it's not real human thinking in here. So you be careful with the syntax, and you test your code at least on the same test cases you have on paper. And you want to test your code thoroughly. Okay. So let me write this code in here. Okay. So let's do a quick demo. Okay. So sum2 num list. What I want to do is I want to write this code. The first thing, in fact, I would not even write this code. This function is supposed to return a value. I'll just return 0, whatever. And I'm gonna first write down the test. I'll say print call sum2 with, like, for example, the test that I have. Where are the test? Is in here. Let me do it in here. Okay. So I want to pass in 1, 2, 3. I call it with 1, 2, 3. I would expect the 3. Let's see what I got. Expect 3. I got, I'll call sum2 by passing in 1, 2, 3 to it. Right? So by doing this, I'm saying I'm calling this thing and I can run my code. Right now, it's not going to work, right? Because this function really doesn't do much. So Python sum2.py. I'm calling sum2 with this thing. I expect 3, I got 0, as expected. And you should write down all your tests. You should write down all your tests. So let's write them down. Okay. The next thing is 2, 4, 6, 8. I'm expecting a 6. And I got what? Let's pass in the right. 2, 4, 6, 8. The next thing is 1, 3, 7. 1, 3, 7. I'm expecting a 4, right? I'm passing 1, 3, 7. I'm expecting a 4. The next thing, -1, -2, 0. -1, -2, 0. I'm expecting -3. Let's see what we got. -1, -2. And then I pass in 0, 0, 2, 0, 0, 2. I'm expecting a 0, right? You just write it out. You only have to do this once. 0, 0, 2. I'm expecting a 0, and let's see what we got. And now some of the trickier ones. I think we have maybe a few more. Now if I give you an empty list, I'm expecting none. And let's see what we got. I pass in a 7. I'm expecting a 7. Let's see what we got in here. Okay. And now I pass in a long string, a long list. 1, 2, 7, 8, 10, 20. And I should get a 3. Let's see what we got. 1, 2, 7, 8, 10, 20. And I think that's about it, right? So those are all the tests we have come up with. And we'll see what we got, right? Right now, I'm gonna fail on everything. Right? Because I didn't really start the code. But by having this return 0 in there, your code would run. It just, I'm expecting all these values. I always get 0, as expected. And you say, well, why do you do this? Because if you start to write this code, you can just run this code to test if a function is good. It's like you have these testers watching you. Okay, so you say, okay, I finished. Did I do it good or bad? Just run the code and see if you pass all the tests. If you pass all of them, you're good. If you couldn't pass all of them, then there is something wrong with most likely your implementation, because you have tested them on paper. It should work, right? So that's the idea in here. Now let's do this one. So we'll say, okay, if the list is empty, how do I know if a list is empty? Right? If the length of the num list is 0, we'll just return none. Right? That's if statement. And then how about if we only have one thing? If the length of this num list is the same as 1, I would return num list 1. For example, only one thing. I got it. Otherwise, I would return the sum of the first two things. Return num list 1 plus num list 2. All right. Looks good. Okay.
I have a quick question.
Hold on 1 second. Okay. So for this one, we have the length equals to 0, 1, and then the test. And we put the test ahead of time. Okay. So you can try to put it after and see how it goes. Okay. Well, what's the quick question? Sorry, what's the question?
Wouldn't it be num list 0 since it's the 0th index and not the first index?
Yeah, I'm trying to make a mistake in here. So,
Oh, okay.
okay. So to demo how you fix it, right? So okay, this is the code that I'm playing the role of a student, right? We make mistakes. So what if there is a mistake in here? And I don't know if that's a mistake. I don't have another person telling me there's a mistake. How do I find it out? Right. So I would say, let me run it. Oops, my code crashed. Right, my code crashed. Don't panic if you see a crash code. Python is very nice to tell you what happened. You look at it in this file in line number 15, and say, I'm calling sum27. And in here, index is out of bound. What is this thing? Line number 5. So the last thing, in fact, is the spot where the error have occurred. So if you see several error messages, that's the last thing in here. This one. This one saying, oh, it's a problem. Okay, and then you come back to lectures and you go see the tutors. This is 0. And similarly, you may realize, oh, this is 0 and 1. Right. And for those of you, if you make a mistake by checking these errors afterwards, your code would also fail. So you kind of want to check for errors or special situations ahead of time before you start to handle the normal situation. Now let's try to run the code. Okay. So I'm expecting 3, got 3. Expect 6, got 6. You have 4, -3, 0, none, 7, 3. All right, looks like everything is good. And now you are pretty confident when you mark your code, you're going to be okay. Later in this summer session, we are not going to give you all the tests. In other words, you click on mark, oh, you passed, for example, 5 out of 5. But we may have 20 test cases. We only show 5 in here. So in other words, oh, I passed all these tests. These tests are maybe normal tests. You may fail other situations. So you want to test your code thoroughly by yourself. Okay. Any questions about this part? All right. So let's if there are no questions, we will move on to the next topic in here. Okay. So the next thing is for PA2, right? Let me talk about PA2 briefly in here. So for PA2, what you have in here is still on the 20th, right? So you have 3 functions: dining hall menus, count the exact match, validate email. Right, so you need to write 3 functions, and basically what you need to do in here is, for example, dining hall menus.py, you're given 2 lists, and you need to manipulate those 2 lists using loops. That's what we'll learn in a little bit. Okay, so you want to have the test cases properly on paper, come up with a strategy to solving it, and then test it thoroughly before you mark it. Okay. So this one, the first one is about list manipulation. You're trying to find the difference between the two lists. The other function is called count the exact match. You're given some text and a query. You're going to take two strings, and it's going to return the number of exact matches between them. Okay. An exact match is basically the locations that are the same. That's the exact match. Again, design test cases thoroughly. Okay. The last thing is validate email. So if you have an email, we want to know if that email address is legitimate or not. You're given the email address and the suffix of the email. There are certain rules in here, so make sure you follow these rules. Design your test cases thoroughly. Okay. If there are any questions about the specifications, you may want to either ask on EdSTEM or go see a tutor. We do have tutor hours available. You can see the tutor hours on the calendar, like Google Calendar, in the syllabus. Okay. So this is the PA. You do need to use a little bit of string manipulation for the last example. So there is a video recording of what you can use. For example, I have a video recording, and you can also see it in the Tuesday lecture. So in here, you can see there is this video recording. Okay, it kind of give you a demo of how to use index. Index is basically find, right? Strip would remove the leading space and trailing spaces. Split is gonna split a string based on the separator. Lower, upper, they are also useful. So I would strongly recommend that you watch the video recording, and they may come in handy for the last like validate email assignment. Okay. I think in the slides we also have some exercises. Not in this slide, but for I think next week we have some exercises about. Sorry, now for Thursday we should have some exercise about strings. So due to time, I'll just ask you to watch the recording in here. Okay. Now, I do want to spend a lot of time today talking about loops. Okay. Loops is the number one hurdle for beginners. It's confusing, you know. So loops, basically, people say loops allow you to repeat an action many times, which is true, right? Which is true. But loops can also give you many other functionalities. So a lot of times for beginners, sometimes people say, well, when do I need to use a loop? When do I need to use a loop, right? Under what situations loops would be necessary? It's like when you have a lot of things. In general, if I say, hey, print out 300 hellos, and a lot of you will immediately think, oh, that's a loop, right? I just need to repeat this in 300 times. That's it. But there are other situations that loops are implied, but you don't see the repeating part. Like, for example, you say, I'll go through this list, go through this string. This doesn't seem like I'm repeating anything, right? So when you have English words like go through something, it basically means you need to use a loop, and you're going to look at the individual elements one after another, and that's repetitive stuff. Okay, so sometimes I do see our students struggle with this. Go through this list, go through the array. That's when loops are necessary. So number one is repeat. This is in general easy. We get it. Number two is you go through something. Number three is you need to generate location or indexes. That's when loops are also necessary. You say, oh, I need to look at a region in the list. Like I have a list of whole numbers. They can be negative, they can be positive. I want to look for a region whose sum is the highest, is the largest. Or you say I have the stock price of a company in the past year. I want to find the longest streak in this list of stock prices that is constantly rising, like non-decreasing stock prices. How do I do that? You need to generate a location, and that's when you need loops. Okay, so these are the situations where loops are necessary. As you write more and more code, loops will become natural. Okay. There are in general two kinds of looping structures. In this class, we use more for loops, but while loops is equally useful. Okay. So for loop means you repeat something X times, or you go through an array, or go through a list, go through a string. That's when you use for loop. While loops are the situation where you're gonna repeat something until a flag is set, or until something has happened, right? So for example, you say, I have a string, go through the string and count how many letter A's there are. You can easily go through it, right? So use a for loop. And then if I see a letter A, increase the counter by 1. That would work. But for while loops, you say, well, I'm going to ask user for a strong password. The password should have at least 2 uppercase, 2 lowercase, a digit, and a special symbol. I will keep asking user to give me the strong password if they keep giving me weaker ones, right? So basically, how many times would it take for the user to do it? Normally, you have no control on that. So that's when you use while loop. While the password is not strong, I would keep repeating. And that's the idea. Okay. So for loops, normally you know how many times you're gonna run. It's gonna run n times. You're gonna run the length of the list, and every time you're in general you're looking at one element after another. That's what you do. While loops is more flexible, and which make it a little bit harder to use. But every for loop can be converted into a while loop, and vice versa. Every while loop can be converted into a for loop. Okay. Questions about the basic idea of loops? All right. So this is the for loop. So we say for something, this is a variable. Okay, so that's a variable that you can create. In is a keyword, and you can this thing can be a string, can be a list. If it's a list, so this thing can be a list. The element is each of the data in the list. If this thing is a string, then we're looking at individual character in the string. There's a colon, and then you have the statements you want to repeat in here. Okay. Are there any questions? Okay. So let's look at this example. What am I doing here? For E in 8, 11, 12, 30, 100, 11, this is like the sequence of classes that you can take in our CSE program, right? Let's say the first thing is E would take the value of 8. So E is a variable, E would be 8, and I print E, then 8 will be printed out. In the next round, E would take the second value. So E would change from 8 to 11, and then 11 will be printed out. Okay. And then I got a 12 in here. then it'll be 12, 30, 100, 101. That's what we have. Any questions? So basically, this variable would take the value of each of these elements. Remember, you are not accessing the elements themselves, it's just individual element in the list. Okay. All right. So let's look at this example. Okay, let's look at this example. What will be printed out in here? Let's vote in, please. All right, so let's work on this. So the answer is D, right? A lot of us voted for D. Let's check. So if x is mod 2 is the same as 0 in here, then we are looking at this is true, right? So this is even number. And x must be bigger than 6. So these are the two conditions we must satisfy. In here, we have 4 is good. Oh, sorry, 4 is not good. 4 is even but not bigger than 6. So 8 is good, 10 is good, right? So D is the right answer here. So that's the for loop. Okay. Are there any questions in here?
I have a question.
Okay.
If that condition wasn't there and it just said print X, would it just would it just print all the entire list?
Yes, it will.
Okay. Thank you.
Any other questions?
So if the compare sign was, so if it was x modulus 2 or mod 2 equals 1, is that odd?
Yeah.
Okay.
Any other questions? All right. So next one. For this one, so what does this function do? What does this function do? All right, so let's stop the voting here. Okay, a lot of us voted for B. If you look at it, we're saying the number of values in here, and that looks right, right? So C equals to 0. If you're given this number of list, you are doing for every number in this list, you're increasing C by 1. So basically, if you have 5 data, then you're going to increase C 5 times. C would be 5. So basically, this is the length of the function. This is the length of the list. And you can add up a few things. If you change it, for example, if you say I want to add up everything in the list, instead of saying C equals C plus 1, you can say C equals to C plus n. This would add C with n, add C with every data in the list, and do it. So if you change that to n, then A would be the right answer. Okay, some of us voted for A, but this one doesn't add up all the data. What is C under the definition? I don't understand. So there's a question, what is C under the definition? This is a variable. You created a variable in there. Any questions? All right, so let's take a break. Okay, let's take a break. And then we will come back at 12 o'clock and then we'll continue. Okay, so we'll continue with the next exercise in there. So break time, come back 12. Okay. All right, we'll resume in 1 minute. Okay, we'll resume in 1 minute. All right, so let's resume here. Okay, so we talk about for loop, and now it's time for us to know some of the nuances of using the loop to go through a list. Right, this courses, and then for every element in this list, we'll say E equals to E plus 1. After that, I print out the courses. What would you say the output will be for this code? Let's vote in. Yeah. All right, so we'll stop the vote. Okay, we'll stop the vote. It looks like a majority of us voted for A, right? So you are believing that the values in here will be changed. Technically, in fact, it won't. Let me see if I can copy. Oh, I will just write it in here. Okay. I'll just write it in this part. So if I have this list, I'll say nums equals to like 1, 2, 3. Okay. And for E in nums, I say E equals E plus 1. And I print nums. What's going to happen is if I run the code, in fact, the list is not being changed. The list stays put. Say, wait, we just added 1 to every element in the list. How come it's not changed? Well, the answer is we really didn't add 1 to every element in the list. So there is a process, okay? So let me explain here. So nums is 1, 2, 3. And what E will take is E would first take the value of 1. It's like make a copy of 1, put it into E. And then we added E by 1. So now E is 2. And then we copy 2 into E. E is now 2. And then add 1 to it, E will be 3. In the end, we copy 3 in, E is 3. And then we wipe it, be 4. But the list never changed. We are copying out the value from the list into this variable. And then we manipulated this variable instead of the list itself. I hope this makes sense. Okay. Are there any questions about this one?
I have a question. So how do you like change the list?
Right. We'll look at that in a little bit. Not right now. Like
Okay.
in the next few slides, there is a way for you to change the list. What does E stand for? E is just a variable, so you can use any variable you want to. Okay. So this is what happens in here. You can call it anything. So it's just a variable to keep a copy. Okay.
So then why do you put it if it does nothing right here? Or like if it doesn't print out anything?
I don't understand. Say again.
So when you print out nums, it'll just print out the 1, 2, 3. So then what does the 4E in nums do? Like
Well, this loop we want to change it, but it didn't change it. So it's just a failed loop. Right. So it didn't work.
It's like an example of a failed loop then?
It's not that it failed, it's just it basically means the loop didn't get to change the array. That's what it is. Okay. There's one question. What is E plus 1? I'm adding 1 to E. That's what it. Okay. Any other questions? If we change it into print E, would this change? Potentially, right? But again, you are not changing the list. We really want to change the list, but this kind of for loop would not be able to change the list. Okay, that's the whole point I want to make. There are other ways that we can change the list. Yes, we'll talk about that next. Okay, but in this format, you cannot change the list. If you say print E, then you're gonna see 2, 3, 4. Right? If you do that, you're gonna see 2, 3, 4. But this is not changing the list. You're just changing E, and you display E. It will change, but you're not changing the list. The list is still 1, 2, 3. Okay. All right. So the answer in here is still going to be B. Okay, there's no change. It's just because we are copying out for this for loop. You have to understand this value is assigned to E. So basically, you can think E is assigned with forces 0 in the first round, and then you're saying E equals to E plus 1. This is just to increase E by 1. Okay. Any questions? All right. So how do I change the list? You have to use indexes. You have to use indexes. Okay. So in order for you to use index in a loop, you have to think about first thing you have to understand the range, right? So this is a useful tool. So it's a special way for Python to generate a range of things, and this would give you this thing called arithmetic sequence. Arithmetic sequence is the difference between the next element and the current element is always a constant, right? So it's like 1, 2, 3. This is the arithmetic sequence. 0, 2, 4, 6 is also arithmetic sequence. And that's what the range would give you. Okay. And if you generate similar things like 0, 1, 2, 3, and these can be used as the indexes into your list or string, you can change them. Okay. So normally we use ranges to generate indexes. Okay. And this is the format. So range A, comma B, comma step. B and step can be omitted. In other words, you may have just range a single number. That's fine. So you can also, sorry, A can be omitted, B cannot be omitted, step can be omitted. So A, if you omit A, it means you start from 0. If you omit step, step means 1. So what does this mean? You are basically generating this arithmetic sequence. So the sequence I, the ith term equals to the starting point plus step size times I, and I start from 0. It's guaranteed that Ri is less than B if step is bigger than 0, or Ri is bigger than B if step is less than 0. In other words, if the sequence keeps getting bigger and smaller, okay, any questions about this? All right. So let's look at what does range 1, 5 give me? Here. All right. We'll stop the vote in here. Okay, we'll stop the vote. The answer should be A, right? So it's 1, 2, 3, 4, not 1, 2, 3, 4, 5. So it's basically giving out the first 4 data in here. So it's 1, 2, 3, 4. It doesn't include B, right? B is not included. B is not included. 1, 5, 2. So let's work on this one. 1, 5, 2. What would this one give you? All right. So a lot of us voted for C. Let's check. You start from 1, right, with a step size of 2. So 1 plus 2 will give you 3. 3 plus 2, in fact, would give you 5, but we don't include 5, so it just be 1, 3. So C is the right answer. Okay, C is the right answer. Any questions? All right. So that's the answer. How about this one? Which of the following produce 1, 2, 3, 4, 5? Be careful. Okay, not all of them. Maybe none of them. I think based on the choice, at least one of them would give you that. So what is the answer for this one? All right, so I think we have a tie between B and D in here. Let's check. So does number 4 make it? So how about A, right? So this one start from 0, you add 1 to it. So 0, 1, 2, 3, 4. So this one doesn't cut it. How about 5? If you only have one number, you're starting from 0. So 0, 1, 2, 3, 4. Again, B, the number 2 doesn't cut it. How about 1, 6? 1, 6, you have, this is the start, this is the end, and if you omit the step, it will be 1. There's 1, 2, 3, 4, 5. 3 cut it. For 4, you don't have the starting point, so it will be 0, 1, 2, 3, 4, 5. So number 4 have an extra 0. So only B is the right answer. B is the right answer. Okay.
So for list 1 or the first list 0, 5, 1, what does the 5 represent?
The end point.
Oh, okay. Okay.
Any other questions? All right, so it's possible to have one number. One number means step size is 1, start from 0. You have 2 numbers. This is the starting point. The second number is the ending point with a step size of 1. If you have 3 numbers, you just starting, end, and the ending point. Just make sure the ending point is not included. Okay. Now we can change the array, right? So if you say, let me try to change the number, you can't use this format. This is what you need to do. So you say for I in range of, like for example, 3, there are 3 things. We change the values. I don't see so many 3s. Right, so those are 3 numbers. This is the length of the list. So basically, I would take value of 0, 1, and 2. You would say nums I plus equals to 1. And now if you print nums, this nums would change. So you see it's going to be 9, 12, and 13. Everything is added by 1. So if you want to change the list, you have to use the index. You have to use the index. Okay. Any questions? All right. Now your term. Okay, so you are given the list. Your job is to square all the positive numbers in this list. Leave the negative numbers alone. The negative numbers and positive numbers, they may be mixed together. So you have to check if this thing is positive, you square it. If it's negative, you leave it alone. Okay, so this is called selective square. And this is the, I think this is the one. Okay, so I'll give you some time. Can you do this yourself? Selective square based on our discussion of how to use the for loop there. Okay, give me a vote once you are done with this exercise. So what would you do? You have to go through the list, generate the right range, and do it. right? It's 3 minutes. So if you are done with the code, vote in. Okay. All right, 4 of us are done. Okay. Right, so it looked like 5 minutes already passed. 4 of us are done. Okay. So you got to write the for loop with the indexes and use the if statement to tell if a number is positive or negative, and then do it. All right. I think it's time for us to work on this together. Okay, so let's see. So you're given this list. The first thing I want to know is how long this list is. N equals to the length of this list, right? And then I will use n to generate my range for index in the range of n. And this would naturally give me all the numbers from 0 to n minus 1, which is the range of the list, right? So for the indexes. So I will check if num list I is bigger than 0. If it's positive, num list I will square it. It just say equals to, you can do this thing. This equals to 2. Means num list equals num list squared. This means squared by 2, right? Otherwise, I don't do it, and then I'm done. There's no need for you to return anything. So selective square, I'll print out like 1, 2, 3, -1, -2, 5. For example, if I run this code, it's gonna Python exercise.py. Oh, I need to print it, right? So let me put this in. So I say num equals to 1, 2, 3, -1, -2, 5, and then I pass in nums. And then I print nums. Because I need to print it out. You can see the positive numbers are squared, 1, 2, 3, 5. Negative numbers are left alone. Okay. That's what we have in here. Any questions about this? All right. Are there any questions before we move on to the next exercise in here? All right. So the next topic is while loops. So while loops is another way for you to repeat. You in general have this condition as a while this condition. This condition will be a Boolean expression, can be true or false. And then these are the things you want to repeat. For example, if I say while equals input 5, is our input, and whatever this read in, if this input is not 5, I will keep asking user for input. That is what I want to do. So if you look at it, if I run this one, I need to make sure I change it 5 and make sure the indentation is good. If I now run this code, oh, there are some quotes. We'll copy from there. Okay. It's gonna say if I enter 6, it's gonna keep asking me to enter stuff until I enter 5. That's when it says it's done. Right. So long as this thing is good, you stay in the loop. So keep in mind this condition is a positive condition. So if this thing is good, you stay in the loop. Okay. So that's the idea of while loop. And you don't know how many times it's gonna take me before I enter 5. So you just have to use this kind of looping structure. Makes more sense here. Okay. Are there any questions? This is doesn't equal to. That symbol is doesn't equal to. Any other questions? All right. So let's look at this one. I want to print out 13579. Which one of them would give me this exact value? Be very careful with the off by 1 problems. Okay, so let's vote on this one. So more than one of them. Take your time. All right, so let's work on this one. Okay, so a lot of us saying D or E. So let's see, look at A, right? So I equals 1, I is less than 9, and I already can tell this one won't work because I can never be 9, right? And I need to print out a 9. So this one would never work, but nonetheless, we say we start from 1, right? I is good, and then I becomes 3. I is still less than 9, so I print out 3, and then I becomes 5. 5 is less than 9, print out 5, I becomes 7. 7 is less than 9, which is good, and then I becomes 9. And that's when the condition is bad, so A doesn't work. How about B? I equals 1, I doesn't equal to 9. Again, I think this one would print out 1, 3, 5, 7. Because once I becomes 9, this thing becomes false, out. So B doesn't work. How about C? I equal to 0, I is less than 5, print out 2i plus 1. So when I is 0, so 2 times I plus 1 would give me 2 times 0 plus 1, which is 1. And then I becomes 2. And then, then I becomes 1, right? I is 0, and now it becomes 1. Is in the next round, 2 times 1 plus 1 is 3. And I becomes 2. 2 times 2 plus 1 is 5. I becomes 3. And I becomes 4. So C is good. I didn't see anyone voted for C in here. The next thing, I start from 1 in here. I doesn't equal to 10. I'll print out I will see 1. And I becomes 3. And then I becomes 5. I becomes 7. I becomes 9. And 9 doesn't equal to 10. So I becomes 11. 11 doesn't equal to 10. I have 13. So this loop is going to run forever. So the only correct answer is C. The only correct answer is C in here. All the other ones are off. Are there any questions about this?
So why does D keep repeating again?
Why do you think D would stop?
Well, I thought it would stop because I thought like 10 is it can't go higher than 10, so that's why.
Why it says doesn't go above 10? Why do you think it doesn't go above 10?
Because from what I was thinking, it's like kind of like the index or the range. So
But right, this is not a range, right? We're not using range. If you have a range, it doesn't go above the limit. But in here, it's not range, so it can potentially go above. Any other questions? So the only answer in here is C. Okay, the only correct answer in here is C. All right, so how about this one? What will be printed out by this code? Num minus equals 1 means decrease num by 1. What will happen here? What's going to be printed out in the end? So what will be printed here? All right. We will stop the vote. Well, first thing, there won't be many printed out because this print is just a statement after the while loop. Only num minus equals 1 is part of the while loop. So I only print out one value. So if you voted for A or B, definitely it's not correct. We're not printing out things. So only the things indented that part of the while loop. This print is not, so A or B are wrong. That's a majority of our votes, in fact. Now, some of us voted for D, which is the second popular choice. So let's check. Do I get 0? Do I get 1? So num start with 3. It's true. So num is bigger than 0. So now num is 2. And still true, right? It's bigger than 0. Now num is 1. 1 is still true. So num is 0. When this thing is 0, this part becomes false. You are out. Once this thing becomes false, you don't complete the loop body anymore. You directly jump out. And then so D is the right answer. Okay, D is the right answer. All right. Are we good? Any questions? How about this one? You have this one. Input enter number, I add it to total. And assume the program asks input from user. The user entered 1, 2, 3, -1. I'm kind of using the -1 as a flag if you look at this part. What will be printed out? All right. We'll stop the vote now. A lot of us saying A, right? So I mean, I have a bunch of numbers and then I have -1 here. Well, the answer is, in fact, is unfortunately not 6. In fact, the answer is 5. The answer is 5. Why is it 5? It's because, so when you're reading a number, you typecast it into an int, right? And then you add it to total. So total and num, they're both, well, for one thing, sorry, I think I made a mistake. In fact, the answer would be C. Sorry, the answer would be C. I made a mistake. Num, in fact, is undefined in here because num doesn't equal to -1. This is the problem, right? So you have never defined num, and then you start to compare num with -1, and that's the problem. So you may want to say, I define num first, and then add them up. Okay, then add them up. So what should be the initial value for num? Like I said, I want to define num in here. What's the initial value for num? Here. So you must define num first. What is a good value for num to start with? All right. We'll stop the vote. A lot of us said A or B. In fact, both A and B are correct. So D is right. C is not good because the only thing that I care about is I get into the loop, so I can start reading the data. Right. So the only thing that I make sure is num is not the same as -1, because if that's the case, this condition will be false. You're out. So it can be 0, num can be 0, num can be 1, num can be anything, because it's going to be overwritten by this input immediately. Okay, so that's the first thing. So when you use a while loop, if you have some sort of variable in here, you want to make sure that that variable is created before. Okay. Now, given this thing, I'm just picking 0 as the value. We already said, well, I kind of went ahead of myself. The answer is going to print out 5. It's not going to print out 6. Okay. And the reason is this. Let me run it so you can see the result. Right, so doesn't equal to -1. Put it in. Right, looks good. So we say Python exercise.py, enter number 1, 2, 3, -1. The total is 5. The total is not 6. Why is not 6? It's just because when you enter, for example, let's say I enter like 1, that's good. So total is not 1. Right? And then the next round I enter 2, total increased by 2. No, total is 3. And then next round I enter 3, total is increased by 3, total is 6. And then in the next round I enter -1, total would be decreased by 1 before you're out of this loop. That's when num equals to -1. Right? So in other words, you added with this -1 by mistake. So how do I avoid this mistake? There are multiple ways to do it. You can have an if statement. If num doesn't equal to -1, you add it to total. And that's one way. So you don't add that -1 in there. This would solve the problem. The other way is this. You enter this number, right? I'll check. If num is the same as -1, I'll break. Otherwise, I would add it to my total. That would also work. So if that's the case, a lot of times you just say, I'll have a while true here. So this is the infinite loop. I'm only getting out when you give me a -1. Otherwise, I'm adding it to my total. The last thing you can do is I'll just add it, whatever. And then in the end, I'll say total minus equals to -1. I'll just take it out. And you just have to change the condition to be num doesn't equal to -1. I would say out of all these choices, depending on how many numbers you're adding, if you're adding a billion numbers, I would say this is probably the best choice, because you don't have to judge on an if all the time, right? So that's kind of probably the easiest way for you to fix it. Any questions about this? All right, let me see. Y6 will be substituted by 1 because once you're reading a -1, this -1 is added to total before you get out of the loop. Because once you're reading -1, you finish the current round of iteration, you come back, check the condition, and that's when this condition becomes false. That's when you're out. So because -1 is the marker, we inadvertently added the marker to the total before we get out. All right, so let's take a break. Okay, come back at 1 o'clock, and then we will finish the remainder of the class today. Okay. All right, so break time. All right, break time. All right, let's get ready for the last session today. Okay. All right, so we finished for loop, while loop, range. Now just we have a couple more things: break and continue and import. Let me see, are we ahead of schedule? I think we are slightly ahead of schedule. But I think we're okay. Okay. So first thing is import. Import is a way for you to borrow codes from Python. It's just like you borrow books from the library, right? You can borrow them and use them. There are certain libraries that you can use directly, like random or math. They ship with Python, but there are certain modules that later on, like we're gonna process pictures, and that's when you have to import a file. So there are several ways you can import these libraries. Okay, the first way, let me try to open up our Tuesday over here. Okay, so let me bring this up. If you want to say, I want to import, so you can say import math. And now you can use a lot of the functions from the math library. So math dot, like cosine math dot pi, right? So cosine pi, what's cosine pi? You can say x equals to this. You can call a function, and you just have to use math dot to use those functions. What's cosine pi? I think it's 91, right? So if I print out x, I'm expecting a -1. Python exercise.py, so it's -1. Right? It has many other functions that is useful in math, like a math calculator. There's another way that you say from math import asterisk. Asterisk is everything. It means I want to import everything from math into my program. If you import in this way, you can say x equals to cosine pi. And this is okay. So it's going to give you the same answer. You don't have to use math dot. You don't have to use math dot. And then why don't I do this all the time? It's easier because it's possible that you may have several functions that have the same name. Then it's beneficial to say this cosine function is from the math library. Another cosine function is made by my own. So you can use the dot to differentiate a few functions with the same name. But in this class, it really doesn't matter too much about which way you use. normally, if it's a system library like math or random, you can say import. Normally, this is what we do. So import math, random, and that's good. To import it two libraries. That's normally what we do. But if it's one of our own customized library, then you want to say from math import something. Okay. So this is kind of how you can borrow the tools from Python. Now, if I have a random, right, I have a random, and then the words are live, love, and laugh, and the random dot randint is a function that would return a value between the starting point and the ending point, including the ending point. In other words, if it's a randint 2, 5, it's going to give me a value potentially as 2, 3, 4, 5. Okay, so the ending point is included. If I have this code, what do you think would happen? All right, so the answer is, I think the popular choice is B, and that's correct, right? So it's going to print out one of these values, live, love, and love. So one of them, because this would generate a random value between 0 and 3. 0, 1, 2, 3. I don't know which one it will come out first and how many times a number is generated, but because of this potential to generate 3, so sometimes it's going to go out of bound, right? Sometimes it's going to go out of bound. As well, when, you don't know. So when you design a code with some random behavior, sometimes it's hard for you to debug, because sometimes you don't see your code crash. Sometimes you do. So it can be a little bit tricky to debug. But you, in this example, it's gonna basically potentially run out of bound in here. There's one question: what does randint mean again? It means it's gonna generate a random integer between this value and this value inclusive. The length of words is 3, so it's going to give me a potential value between 0, 1, 2, and 3, including 3. And this 3 is going to give me trouble. Okay. Any questions? All right. So the last thing for today is I want to talk about break and continue, and then we can kind of stop there. So for break and continue, they are useful statements for you to alter the flow of your loop. In general, they exist in the loops. So break means you get out of the loop before it finish the whole thing, right? So it's, for example, you say, when do I need a break? For example, you are saying, I am trying to check out of the 18 students who are here today, if I have any biology majors, right? So basically the idea is I will loop through every student in the class. I will ask, so student 1, are you a biology major? Student 2, are you a biology major? I'm going to keep doing this, so my code would run at most 18 times. But when I see a biology major, when some student told me, oh, I'm a biology major, then I don't have to ask the remainder of the student anymore, because all I care about is, do I have a student that is a biology major? The answer is yes. Right, so that's when you say, oh, if you see a biology major, break. So normally break is kind of used in that situation. When you're looking for an answer, once that event has happened, you just get out of the loop. Continue is slightly different. Continue is to say, I'm running in the loop, but sometimes I want to do something, sometimes I don't, depending on the situation, right? So continue would allow you to skip the remainder of the current iteration of the loop and then continue to the next round. So continue doesn't get you out of the loop. It will just allow you to skip part of the loop. When do I need to use continue? It's something like this, right? So I want to know the average GPA of CSE majors in this class. The average GPA of the CSE major. I only care about CSE major average GPA. So this is what I will do. So for every student in this list of students, and I check. If this E is not CSE major, if the student is not CSE major, I say, okay, don't even bother with the GPA question, because that's not what we're trying to look for. And this continue statement would say, skip the rest of the iteration. What do I do for the rest of the iteration? I would say, ask your GPA, and then do the math, right? So if this student is CSE major, I don't execute continue, I will ask for the GPA and do the math, and then move on to the second student. Are you a CSE major? If the student is not a CSE major, continue would run. That means ask for GPA, do math will be skipped for that student. And then for the third student, and we repeat. So continue doesn't get you out of the loop. It will kind of allow you to determine if the second part of the loop body is executed or not. Okay, so that's the difference between break and continue. Break is you get out, and for continue you skip the rest. Skip the rest of the current iteration, and then continue with the next iteration. Yeah. Iteration means, like for the student, you have 18 students. Student 1 is one iteration, student 2 is another iteration, student 3, student 4, and go on. Okay, that's the meaning of it. Any questions about this? All right. So like break statement is used for you to get out of the loop prematurely. Okay. So normally you want to be inside the if statement. Basically, you are saying if the specific condition has occurred, break out of the loop immediately. Even if there are still things that needs to be run in the current iteration, you're out immediately. You don't do anything else. You continue after the loop. Okay. So this is normally what happens. You have a loop, either it's a while or for. You have something before the break, and then you have the condition. You may have things after the break. When this break condition is true, you're gonna get out the loop immediately. You're gonna skip this one. You're not gonna say, I'll finish this part before I get out. No. Okay, so keep this in mind. Now let's look at this example. I have message equals hello, and then I have this loop. What do you think will happen here? All right. We will stop the vote in here. Okay. Look at A and B are the most popular, HE or HEL. I think that's where the problem occurred. So the length of message is 5, right? So we're looking at for every letter, if it is L, I would break. And this and equals to nothing. Normally, if you print something, it's gonna append a new line. This and equals to just empty string means don't append a new line. That's why all these HEL, they're gonna be printed in the same row. Okay, so the first letter is H. H is not the same as L, so I'll print out H. And then I print out the E, right? Then the first L. This L, this part is true. So I'm breaking away from the loop. I'm not gonna finish this print statement before I get out of the loop. So it's gonna be A. The answer is A. You're not gonna finish the current iteration. Once you break, you're out immediately. You don't finish the current iteration of the loop. Okay. Any questions about this? All right. So for continue, again, continue usually hides inside the if statement. If the continue is executed, this part will be skipped and you don't get out of the loop. You come back and run the entire loop again, right? But for the next iteration. Okay, so that's what continue would do. It will allow you to skip this part. Now, what will happen here? So the only thing I changed is I changed from break into continue. That's the only change. All right. A lot of us said D. I think we got this one. Okay. So we'll stop the vote. The answer is D. Basically, if you see L, you're basically saying if it's L, you just skip this print. So you don't print L. So it's gonna be HEO. Okay, you don't print any L. Okay. That's what this continuous statement would do. Are there any questions about this? Okay. All right. Let me see. I think we still have some time. Let's push it. One more topic. I'm sorry, I've been talking about so many different things in a single day, but it's summer session, so everything is all nested together. So the last topic, this is definitely the last topic for today, is nested loops. So sometimes you say, I need a loop to be inside the loop. Okay. So when do I need a situation like this? Normally, you are looking at, you have the outer loop, you have the inner loop. And what these looping structures really, in general, give you is you need 2 counters. You need 2 counters or 2 indexes. That's when you use a nested for. Compare nested for with 2 loops, loop 1, loop 2. In general, these two loops are separate from each other, so they do not. In general, you don't have two counters or two indexes, but only when you say I have these looping structures that I need to, for example, I need to know I and j, and they are kind of two locations in the list, then that's when you use a nested for loop. The other situation is I have a grid of like xy coordinates. Then the outer loop can be x, the inner loop can be y, and I can go through the entire grid. That's what nested for loop will do for us. Okay. So if you look at this example, for I in the range of 4, for j in the range of 2, I print out the asterisk. Let me ask you first, what will be printed out in here? What will be printed out? Let's vote in, and then I will explain what a nested for loop really does. All right, so we have a disagreement in here, A and B, right? But I think the disagreement is we're going to print out 8 asterisks. I think that's right. So this and equals to nothing. I think I talked about it means don't append a new line. So everything will be in the same line. So it's going to be A. Yeah, I'm going to print out 2 rows in here. Why? So basically the idea is I would start from 0, and then j would be 0 and 1. Every time j takes a value, I print out the asterisk. And then I becomes 1, j would restart from 0, 1 again. I becomes 2, j would be 0 and 1 again. I becomes 3, j would be 0 and 1. So altogether, you're going to see 8 asterisks printed out. There is no new line in here. If you want to have a new line, you can have empty print over here. Align with this 4, then B would be the right answer. Okay. Any questions about this? So for nested for loops, the outer loop in general goes a little bit slower. The inner loop goes a little bit faster. It's like the outer loop is like the hour arm of the clock. The inner loop is like the minute arm of the clock. The inner clock rotates a full round before the outer loop moves just a single little bit, right? So if you look at this kind of nested for loop, I would go from 1, 3, 5, 7. So I would be start with 1. J would be 2, 4, 6, 8. And then I become 3. J would be 2, 4, 6 again, and go on. So that's kind of how the whole nested for loop structure is used. I think a more useful way to think about the nested for is in the context of lists. When you say I have one list, I have another list, I want to say for each of the elements, like for example, for this PA, right? You have 2 lists, they are the menus. You say, okay, I want to find their difference. Basically, all I need to do is I want to check, right? Given the element in one list, I need a for loop to do that, right? I want to check, is this element in another list? You can use another for loop, or you can use the in, like the membership function, the in function to check. Either way is fine, right? So in general, when you use nested for, you are either dealing with a single list with 2 index locations you need, or you're looking at a 2D list where one is x, the other is y. Are there any questions about this? let's look at this example, and then we can call it a day today. So n equals to 4. This one is a little bit tricky. Okay, so make sure that you focus on the alignment. So who owns what? Be very careful here. So let's say what will be printed out for x. What's going to be the value of x? Interesting. This would cause a lot of us think this is going to cause an error. I'm not sure where the error might come from. All right, so let's check this one. It looks like this one is harder for us. So n is 4, x is 0, right? While n is bigger than 0, that's true. And then I would go from 0 to basically this for loop would run n times, right? If n is 4, it's going to run 4 times. I increase x by 4, so x is 4. And now this part means half n by 2. And this, remember, this is integer division. It's going to throw away the decimal point. So 4 divided by 2 is 2. So now n is 2. Go back here, n is still bigger than 0, so that's true. For I in range of 2, so this one would increase x by 2, so now x is 6. And now I half n is now 1. N is still bigger than 0. Now this thing is going to run 1 time, right? Because n is 1 now. So this thing is going to run 1 time. X would be 7. And n divided by 2. 1 divided by 2 equals to 0.5. And the dot 5 is thrown away, so n is now 0. That's when this condition becomes false. So when you print out x, you're going to see 7. C is the answer. Okay. Questions about this? All right. I think let's we'll do 2 sum on Thursday. I think we had enough today. To summarize, what did we talk about? We talk about loops. That's the most important thing. We also talk about how to get started with your code on paper, design the test cases. Okay. And then we talk about break, continue statement, and then in the end we touched on nested loops. You can put a while inside the for, you can put a for inside the while, you can have 2 for loops, you can have 2 while loops. There's no limit. You can have 3 layers of loops. Okay, it just the more layers you have in general, the slower the program will be. I think we will stop here today. If you have questions, I'll be happy to answer them. But other than this, we're done today. Okay. I will see all of you on Thursday. Don't forget the lab tomorrow. the quiz on Friday. Okay, don't forget that. All right. Thank you, everyone. Okay. Are there any questions?